Hello, scholars. Let's see what's in store for us today. Today we're going to learn about order of operations, where it comes from, why it's important, and how we use it. Let's start with the where. The term order of operations became well known in the late 1800s and the early 1900s, when textbooks became more common. But the idea is much older. As early as the 1600s, it was common knowledge among mathematicians to multiply before adding. The concept grew alongside mathematics into what it is today. The why from before is consistency. In order to do math consistently, people needed to agree on a set of guidelines to help us work through math problems step by step. This was so everyone would be able to do the same math problem and reach the same answer. It also lets mathematicians know that the people reading their work later will understand what they were trying to say. These steps are called order of operations. These rules tell us to start with operations that are more complex, like exponents, and move to operations that are less complex, like addition. This makes more sense when you understand that many of the more complex operations are just shortcuts for the less complex ones. Exponents are a shortcut for repeated multiplication, and multiplication is a shortcut for repeated addition. This rule set was also designed to minimize how many parentheses we need. Let's take a look at this expression, both with order of operations and without. This equation, for example, would be an absolute mess if we were forced to use parentheses to show the order of everything. Here's how it might be evaluated without any of these rules. Thankfully, order of operations is standard around the world, so we can write our equation like this and know that anyone who sees it will read it the same way. Here it is again, using the given rules. Without the rules, we would have to use a lot of parentheses to get the result we were aiming for, and it would look like this. How we use it is to simply solve a problem step by step, in the order that it was meant to be. PEMDAS is the mnemonic device that we use to help us remember what order to solve math problems in. Each letter of PEMDAS stands for a different operation inside the problem. P is for parentheses, E is for exponents, multiply and divide are the M and the D. The last are A and S for add and subtract. This list tells us which operations to start with and which come next. This lets us break down a math problem into smaller chunks while solving it, and to write complicated problems as simply as possible. Note, we call the completion of each step evaluating. So you evaluate exponents, then you evaluate multiplying and dividing, and so on. Parentheses say, do this part first. So we evaluate anything in parentheses first. Exponents are next. Evaluate anything with an exponent that we can in this step. Then we check for multiplying and dividing, which both happen on the same step. We will work our way through each instance of multiplication or division from left to right. Finally, we do any addition or subtraction in order from left to right as well. Well, there you have it. what order of operations is, where it comes from, and how to use it. Have a great day, and I will see you next time.